Hello. This is Math 1324, Chapter 5, Section 2, Example 6, I think. Something like that. Anyway, a father opened a savings account for his daughter on the day she was born, depositing $1,000. Each year on her birthday, he deposits another $1,000, making that last deposit on her 23rd birthday. If the account pays 5.75% interest compounded annually, how much is in the account at the end of the day on his daughter's 23rd birthday? How much interest has been earned? Okay, so this question is tricky. Let's go through this. The question says, or the question that we want to answer is, how much is in the account at the end of the day on his daughter's 23rd birthday? And then the second part is, how much interest has been earned? So there's two different questions here. The first question seems easy and similar to what we've done in the past. And it is similar, but there's a small twist thrown in here that you have to be careful with. So he opened a savings account for his daughter on the day that she was born, depositing $1,000. Each year on her birthday, he deposits $1,000, making that last payment on her 23rd birthday. If the account pays 5.75% interest compounded annually, how much is in the account? Okay, so I want to kind of go ahead and make this thing here. And let's just think of this as a timeline. 0 is when she's born, 1 is her first birthday, 2 is the second birthday, and so on and so forth. And what is the father doing? Well, on that immediate first birthday, he put $1,000 in there, right? Or sorry, on the day of her birth, he put $1,000. Then he put $1,000 on her first birthday, $1,000 on her second birthday, and so on and so forth. And if we added all this up, I have a question for you. If you add all this up, what would it equal? Well, 1,000 plus 1,000 plus 1,000 plus 1,000, all the way over here. A lot of people would think 23, right? Well, it's not true because you also have to include 0, this times 0. So think of it this way: 0 is the first payment, 1 is the second payment, 2 is the third payment, and so on and so forth. So this 23 is actually the 24th payment. So here, the total number of payments is actually 24, not 1. Sorry, not 23, right? So in this case, we have to be a little bit careful with that. In fact, you should think of this as extending to this -1, right? Well, should use purple for this. I should use green. This should be extending to the -1 to make this an ordinary annuity, because at the end of this period is when you make the payment, and then at the end of this period is when you make the payment, and so on and so forth, in order to use the formula that we've been using. So now that we've done this, let's use the formula. Okay, so we don't know how much is in the account. That's what we want to figure out. Capital R is the revenue stream. Well, he's making $1,000 payments. R is the interest rate, and the interest rate is stated right there. So it's 5.75, so 0.0575. N is the compounding annually, which is just 1. And then the T. Well, the T is the number of years, but again, be careful. 1 year, 2 years, 3 years, so it's technically 24 years here. That's why it's a bit of a twist. A lot of people would say 23 for that exponent, but it's actually 24 because you have to remember these are always made at the ends of periods. So if he made a payment here at the 0, that means that this annuity actually began at -1. Okay, so again, the formula is just this. And then just type everything in. Sorry. So it'd be 1,000, and then times the 1 plus 0.0575 over 1, all to the 1 times 24. Then minus 1 all over 0.0575 over 1. Awesome. And then just type it in. So 1,000 times alpha y equals enter, parentheses 1 plus 0.0575 over 1, all to the 1 times 24, right arrow, then minus 1, then go right arrow again, and then type in the 0.0575 over 1 in the denominator. Click enter, and that tells me that it will be $49,145.38. Good deal. And that's how much will be in the account on her 23rd birthday after he had made that last payment. So it's $49,145.38. Good deal. Awesome. So the question now becomes, how much interest was earned? Well, to do that, we have to ask what were the total payments? Again, there were $1,000, and there were 24 total payments, which gives us $24,000. So we're going to take this value, subtract this value to give us the total interest. $49,145.38 minus that $24,000 should be $35,145.38. There you go. And that's how much interest was earned. Awesome. Here's the entire question, and again, this is just one with a very slight twist that a lot of people would miss if you're not careful. Alrighty, well, I'll see you in the next video. Have fun.